Got it or not got it? So now we have a structural hazard. Okay, now please look at here. In which clock cycle we are in? Now in this, which clock cycle is this? Clock cycle 4. In clock cycle 4, so now we are in clock cycle 4. So this is clock cycle 1, clock cycle 1, clock cycle 2, clock cycle 3, and clock cycle. And if we have combined memory, so what we are doing? We are performing an operation on main memory. For the load and store instruction, we are fetching the instruction. So what we are doing? So there will be a stall. How it works? So it's there. So now we can see here. So we have accessed the memory, which is instruction I, and we want to access the memory for instruction J. What is the difference between this and this? This is I plus 1, I plus 2, and I plus 3. So it means that if I plus 3 is any instruction, we need to fetch an I plus 3. Why? We are accessing the main memory for a load instruction which is in the memory stage. So it means it will create a stall if we have a combined main memory. So how does it work? So there is a hazard, and then we will create a stall. So how to access memory at the same time for two requests? So separate instruction and data memory to eliminate the conflict for a single memory between instruction fetch and data. Any question? Okay. How many slides are there? How many slides is this? One slide. How much time did I spend for explanation? 45 minutes. Are these examples there in the lecture slides? This is what I want to say. So that's the reason that you need to look, even if you are not attending my lecture, please look into my video lectures. Again, there is also another type of hazards. Can anyone explain this? May get some bonus point. Should I wrap this up? And please remember, for this hazard I will also. Yes. Yes. Can you explain this? Can you explain this thing? Yes. Okay. Please remember, assume we have a scenario, we have some instruction. Assume I will have explained this with an example. Examples are always good. Let's assume we have this instruction I1. And this instruction I1 is like this: add R3, R4, this instruction I1. Okay, now if we have this thingy, and please remember the table that we did yesterday and the day before yesterday. So basically, so if you have clock cycle 1, now this is my I1 add instruction. Which stage will be there? Fetch, then what? Decode, then execute, then main memory, then what? Is clear? So clock cycle 2, clock cycle 3, clock cycle 4, clock cycle 5. Okay, now in clock cycle 2, so it means that this instruction I1, so now I am saying this instruction I1, this is my instruction I1, will read 2 operand from register file in clock cycle 2. And remember the pipeline figure. In clock cycle 2, please remember in clock cycle 2, what will happen in clock cycle 2 for I1? Please remember. So what will happen in clock cycle 2 for I1? Can anyone help me? Now let's say I1. Okay, now I1 is in decode stage. in clock cycle 2. And remember the figure again. I'm revising the figure, so this is my figure now. In clock cycle 2, we are reading some values from the register and load it into which register? A and B. Okay, so now in clock cycle, so assume this instruction. This is my instruction. This is I1 instruction. Please remember, you will not find this explanation in any book. In any book. So that's the important that you need to focus here. So now in clock cycle 2, I1 is now in decode stage. What will be the value of A here? Help me. What will be the value of A here? Can anyone help me? The content of what? R4? What will be the value of B here? The content of what? Clear or not clear? Okay. Now this is a little tricky. This is very tricky here. Why I'm going to do this is a tricky here. So now we move to now clock cycle 5. We move to which clock cycle? Clock cycle 5. So this instruction move to clock cycle 5. In clock cycle 5, I1. Do we have this instruction I1? I1 is in which stage in clock cycle 5? Right back. What we are doing in right back? So it means that RD will be overwritten. Please remember, RD, R5 will be overwritten, which is in where? Help me. No. This R5 will be overwritten from here. What is this thingy? Remember again, ALU out 1. Here, ALU out 2. Actually, R5 will be overwritten with the value of ALU out 2. And actually, what will be in that ALU out 2? Because in this will be from ALU out 1, and from ALU out 1, it will be actually, if you do it, so it will be actually the content of what? R4 and what? Plus what? Okay, now this is not R3. This is R3. This is my destination is R3. So the value of R3 will be overwritten in ALU out 2, and actually the value of R3 that is will be overwritten with the content of what? R4 plus what? Got it or not got it? This is clear or not clear? Okay, now assume we have another instruction. I2, this is any arbitrary instruction. Let's assume this is my any arbitrary instruction. I2. I2 will be in which stage? Help me. Fetch, decode, execute, man memory, and write back. Am I right? Yes or no? Now I'm coming back to this thing because I'm going to explain this topic. Not here, not this one. Okay. Let's assume we have another instruction, I3. So this is any other instruction. Okay, assume that this instruction is independent. This instruction is independent. I2, then we have I3, and then, what about I3? I3. So if you look at I3, so now why I'm going to do that so that they are independent instruction. This is my I2, this is I3. What about I3? I3 will be fetch, decode, execute, man memory, and what? Write back. Now we have another instruction. Now I'm using another color for that. And now using red color. Why red color? Because red color is important. Let's assume we have I4 instruction. And that I4 instruction is something like this. And R7, R3, and R10. Okay, now I4 is in fetch stage here, decode stage here, execute stage here, man memory stage here, and write back stage here. Now please remember, this I4 is now dependent on which instruction? I4 is dependent on which instruction? I1. Basically, can you see here? I4 is now dependent on I1 based on The content of what? R3. Okay, now think of a scenario. This is very important. Let's assume the initial value of R3 is 2, the initial value of R4 is 9, the initial value of 4, the initial value of R5 is 3. What will be the new value of R3? 4 plus 3? 7. So the new value of R3 should be now what? 7. So this R3 should be 7, the old value or the new value? The new value. It should be 7 or 2? It should be 7. But now there is a problem. Now there is a problem. Now we are now in clock cycle 5. We are now in clock cycle 5. In clock cycle 5, instruction 1 is writing R3. For instruction 1 we are writing R3. But for instruction 4, what we are doing? Because I4 is now in decode stage. If I4 is now in decode stage, so I4 is now in decode stage, so what will be the value of A here? Help me, what will be the value of A here? R3. And what will be the value of B here? What? Help me. R10. So now in clock cycle 5, one instruction is reading, other instruction is writing. But now the problem is that there is only one register. There is only one register. I am also reading this register and I am writing one register. Is it a construction? Is it a structure hazard or not? Can we do read and write at the same time? No. Because read operation is mutually exclusive from write operation. Either you can perform read or either you can perform. Now, assume that we have a register 5 and we are writing in clock cycle 5. So it means, okay, now please remember, now I am formulating the problem now. Now I am formulating the problem in journal. So it means that if this is which instruction? Please remember, now what is the difference between these two instructions? How many? 3. So it means that if, so I am not generalizing it. So this is actually, how can I write it here? This is my I. What will be the next instruction? I plus what? 1. I plus 1. I plus what? 2. I plus what? 3. So it means that if the source of I plus 3 is equal to the destination of what? Help me. I. So okay, now this A is equal to R3. If we are reading from register 5 and the old value, so we will get in 2 or 7, we will get 2. That will create a problem. So what should we do? First should we write what? R3 and then we should read R2 in the next one. So it will create a what? It will create a stall. Because we need to first write R3 and then read R3 in the next clock cycle. So can you see? Now, what I am going to do? So please remember, conceptually, what we can do. So what we can do? So instead of doing that, so then we will create a stall cycle. So basically, now if you do it, I will create a stall cycle. So this is actually fetch, this is decode, SSS. How many stall cycles? Sorry, we have this thing. We have then stall here. S, and S. And then can you see here? Now we move that. So we are not decoding in this cycle, we are re-decoding in the next cycle. Decode, execute, memory, and write. How many stalls are introduced? 1. But how can we avoid this problem? How can we avoid this problem? We can avoid this problem by using some intelligent method. So we can avoid this problem by dividing the clock cycle into 2 phases. So we have, please remember, in the digital system paradigm, we have what? The clock cycle, this is the rising edge, and this is what? Rising edge. So we have the first half or second half? Help me. First half, and this is what? Second half. So we can avoid this problem by writing in the first half. So in this example, what we are writing? We are writing the value of R3, which is in ADO2, which is actually 7. So we write 7 here. We write 7 in R3, and then we read in which half? The second half. So are we getting the updated value or the old value or the new value? The new value. So this is called as an efficient implementation. So in the digital system design paradigm, anyone who did digital system with me, please remember in digital system there are some flip-flops. And flip-flop either operates at the rising edge of the clock or the falling edge of the clock. So basically what we do, so we write in the falling edge and read in the rising edge. So we are writing in the first half and reading the second half. So actually, if you are doing the writing in the first half and reading in the second half, so do we need a stall here? No. But if you are writing only, if you do not allow this overlapping, and if you overlap them, so we will have a problem. Any question? Any question? So what do we do? So if it means that if the source of II3 plus 1 is destination of II3, so there will be stall. Okay, now there will be stall cycle, one stall. If we are not reading and writing at the same time, but if the same thing is here, if the source of II plus 3 is equal to destination of II, and so what we will do? So we will what? We will not create a stall. We will write in what? Write in first half. For which instruction? II or II plus 3? II. Write in the first half for II and read in what? Second half for what? II plus what? Plus 3. Any question? This topic will also be included in your quiz 3. And in the tomorrow lecture, we will explain some more complicated scenarios. For intelligent student like you, it's all for today. Thank you very much.